So let's do a slope field while we are still kind of messing with two-dimensional graphs. So I'll go back to my GeoGebra Classic. The notation is a little bit weird, but if you're there with the kids, it shouldn't be an issue. I'm gonna set up a function that is going to serve as my derivative. I'll call it y over or x over y squared. This will be fun. And I'm just going to create a slope field for this. So if I start typing in the command slope field, I get a whole bunch of things that are going on. I'm going to use the simplest one, which is the second one in my list, slope field. However, there are other things that you can mess with where you can change the lengths of the little slope markers, if you will, those segments, or where they begin. Those are useful if you're trying to make some really nice, for example, images for a test or a quiz. But I'm just gonna stay with my simple slope field. Oh, it's A. So there you go. What I find is that if by turning the grid off, I get a little bit of a better picture. And then maybe making the color of the slope field something brighter also tends to make it a little bit easier to see. Now let's find a particular solution in that trajectory of that graph. So I'm just going to graph the point 1, 0. If I get, or 1, 0, my goodness gracious, I'm having trouble. We'll call that 1, 2. And this is a solution to an ordinary differential equation. So I'm going to go solve, and it's the ODE questions, or the ODE ones. And in the one I like to use most is that third one down, where I'll give it the starting x value and starting y value, which is both the coordinates of point A, and then where I'd like x to end. And then the steps, which is how fine your path will be. So I'm going to type in my derivative, or my f prime, which is going to actually be a in this case, lowercase a, and then it's the x coordinate of a, and then the y coordinate of a, and let's let x end at, say, 10, and my steps will go by 0.1. And this is nice. This is good. All right, so let's get the other direction of the curve this time. So I'm going to duplicate my input, but I'm going to have my ending x value be at negative 10. And there we go. So this is pretty nice, man. This is an interesting shape. Now I am thinking. So anyway, that's a slope field and that solution for a particular point